Okay, hi everybody. I'm very happy to be talking here at this new edition of Buzzwords. And in the next hour, I will talk about analytics in the age of the Internet of Things. But, okay, it doesn't work. Okay. But before that, I would like to say thank you to Joachim and Isabel for inviting me at Buzzwords. And it's my first time here, so I'm very happy to be here today with you. And I remember the first email that Isabel sent me. She tried to find good reason for me to come here to Berlin. And she mentioned how Berlin is lucky with the weather, you know. But I don't know if it's still raining today. I think she was right, because yesterday was very sunny. And I hope the sun comes back this afternoon. But to be honest, I'm not here because of the weather. No, I'm here because I really love Germany, and I really enjoy drinking beer and eating currywurst. And do you have Spezi in Berlin? Yes, because, okay, I used to live in Germany, in Tübingen, some years ago, and we used to drink Spezi in beer garden, but okay, I'm still confused about Spezi, so I think I need to try again. And I'm also talking about technical stuff too, of course. So, okay, so now a little bit about me. I have studied mathematics. Okay, my name is Ludwine Probst, and I have studied mathematics. And after graduating with a master's degree, I decided to join the IT world as a developer. And today, I work at Citizen Data as a data engineer. And Citizen Data is a startup based in Brest, in the west of France, you see, as west as you can get. And with my coworker, we built a platform to store, collect, and analyze data from sensors data. And to do this, I'm using Spark. Maybe you have guessed, I like drawing, so I made a lot of pictures for you today. So, yeah, something more. I would like to share something I really care about. It's about women in tech. I don't know how many women are there today. Okay. But I'm sure you know that women are not much represented in IT and at technical events. So some person pretend that it's a lack of interest from them, but I think that maybe they are not interested in IT because I don't think this is a possible way for them. So that's why I'm very involved in two communities, Duchess France and Ladies Who Code. And Duchess France, it's a group that connects women in IT, and we want to give more visibility to women developers and inspire role model. And I'm sure you know that it's often hard to find female speakers, so we organize coaching for these women to increase the number. And because I think that the developer job is not, I think that people doesn't know what is a developer. We participate in event with high school students to know what is a developer and to know that women can be happy and interested in IT. So now I will talk about the real topic, analytics in the age of the Internet of Things. So I will start by talking about what is IoT and present some few examples. And after that, I will quickly talk about collecting and storing the data from sensors. And to finish, and this is the funny part, I would like to show you how I have stored, collected, and analyzed data from an accelerometer using Spark, Cassandra, and MLlib. Okay, do you guys know how many connected devices do you have? How many connected devices? Yeah? Okay. Okay, because I think 10 years ago you probably have said maybe one or two, but today we have tablet, smartphone with GPS tracking, accelerometer. If you like to play video game, you might have a game console. If you like to run, you might have, I don't know, a smartwatch, a wristband, or a pedometer. And in fact, when you hear about connected device, it's not just about Arduinos or Raspberry Pi, it's also wearables and a kind of sensor that are around us. You have sensors in the black box of a flight, in cars, and in electricity network, and so on. And now, okay, here in this picture, you can see that the number of connecting devices and the connection between them is just exploding. Some sources estimate that by 2020, there will be around 50 billion of connected devices. Okay, now two examples. The first one is about aircraft. So in a plane engine, you've got a lot of sensors, and these sensors can collect thousands of metrics, such as altitude, temperature, acceleration, quantity of fuel, speed, and it can represent terabytes of data. So one common approach was to store and analyze this data after the flight is over, but it's kind of offline analysis. But today, with the sensors, you can store and analyze the data in real time. So you can be more reactive. And you can, for example, monitor the flight, the state of the flight, or detect anomalies. This one is, okay. I was watching the TV some weeks ago, and there was a documentary, and they were talking about this example. Okay. When you talk about IoT, I think insurance, it's not the sector that comes to mind. And here there is a startup, Zubi. They provide a key that is a connected devices, and this device is connected to your car. And the key gives you information directly on your smartphone, okay? And with this information, you can monitor the activity in your car. You can also locate your car, and you can try you can improve the way you're driving. But you can also compute a driving score. So I don't know if it's a good news for everybody here, but the key allows you to compute a driving score. So that means that insurance company can use this technology to reward safe driver and to adapt their price, their insurance price. Yeah? I think it's funny. And to finish the first part, okay, we just saw a few of applications using IoT data. So now you might ask yourself why you should care about this. Okay, we've seen that connected devices are everywhere today. And this device can generate a lot of valuable data. And this data can be used to create better application, detect anomalies, or detect anomalies. And to summarize, analyzing this data opens up a lot of opportunities on how we do business. And I'm sure you can easily imagine how this connected device and this data can affect and change your everyday. I will quickly talk about how to collect this data. And the first thing is time series. Because the common kind of data coming from sensors or connected devices are time series. And I'm sure everybody knows what is a time series, so maybe the easiest definition is any kind of data with a timestamp. And time series can be found on monitoring stuff, signal processing, stock markets. And here is just an example. It's data from an accelerometer, and the time series to the right. If you want to communicate with sensor, there is a lot of protocols. The most popular of them is MQTT, and here are some of the most popular, but I don't go into detail. But for example, DDS is a device-to-device communication. It distributes the data to other device, and it's very good if you have a real-time issues. You can also use MQTT. It's a protocol that connects device to server, and it's great if you want to collect telemetry data. And now, of course, collecting data from sensor can be challenging. So, in fact, most of IoT devices come with a limited CPU and memory resources. So, and machine-to-machine communication can generate way more data than the most applications do. So that means that there is a need for low-energy communication networks. And this is what companies like Sigfox, Wireless, or LoRa are trying to provide. Okay. Before talking about the funny example, let's talk about Autostore data. Storing the data from connected device represents a huge scale challenge, and there are several ways in the market to store efficiently time series. But I thought that several talks will focus on this topic today and tomorrow, so I won't go into detail. Here are some ways to store the time series. Okay, the first one is flat file. If you don't have a lot of data, then you can use a relational database, or also a NoSQL database like Cassandra, HBase, or OpenTestDB. And to conclude this part, I would like to show you a picture. It's an example of how an IoT data pipeline looks like. So, to the left, you've got the sensor and connected device. It sends the data to Kafka, for example, using protocols, MQTT or REST. And a good practice is to store the data, the raw data, before distributing it to other applications, because it can be useful in case you need to replace the stream of event or for debugging. And then your events can be processed in real time using Spark Streaming or Storm, and to provide real-time result or dashboard. And in the same time, you might want to store raw data in Cassandra or HDFS for deeper offline analysis using Spark, Hadoop, or Mout, and so on. So it's a sort of Lambda architecture. Okay, cool. Now it's a funny part for me. It's a concrete example. So, okay. Actually, I like running, and I used to run with my friend Amira. Amira is one of the members of Deutsches France. It's a woman developer. And, you know, she's like a runner addict. She has a smartwatch and has everything necessary to monitor her running performance. So I was thinking about finding something fun to do with sport, sensors, and data. So I looked for some data sets online, and I found this today. Very interesting. It's about the user's activity prediction. So the following example and the data set are inspired from this study. Okay, now the example. So I have data set with data coming from an accelerometer, and I would like to predict the physical activity a user is performing. So I would like to know if this person is running, walking, going upstairs, going downstairs, sitting or standing. Okay? So actually, I will use some machine learning model to perform this prediction, and this is a multi-class classification problem. I have 6 classes here: walking, sitting, standing, jogging, downstairs, upstairs. And I can use algorithms such as decision tree, random forest, or multi-class logistic regression. Now this is the global view of what I need to do. So the data come from the accelerometer, and I have data. I need to clean the data first. Then I will push the data into Cassandra. After that, I want to build my model, my predictive model. So I will use Spark and MLlib to do this. And at the end, for the predicting part, I don't know if you see the picture. Maybe no. Okay. For the last part is the predicting part. And I will use MLlib to do this. The first step is collecting and storing the data. So, first, here as connected devices, I have an accelerometer. I have a smartphone. And in this smartphone, there is a lot of sensors. And there is accelerometer for each axis. And in my case, the data are generated every 50 milliseconds. Okay? But you can specify another time if you want. So, I have an Android application. It collects the data, and when a user is performing an activity, he has to say which one, okay? And the data are collected in a CSV file. Okay, this is the study. The study gave me a CSV file, and then I just took the CSV file and I pushed the data into Cassandra. Here, this is how the data looks like in Cassandra. So I decided to use as primary key the user, the activity, and the timestamp. And in this way, the data are directly sorted by timestamp. So it's very useful for the following. And now it's just my data. So each row is a user ID, activity, a timestamp, and the 3 acceleration. And here, in the diagram here, it's just how it looks, the time series. So, because I would like to build the predictive model. And, if you want to see the code is on my GitHub account. Okay, there is everything. So, but before that, just a few words about Spark. Is anyone not familiar with Spark? Okay. So Spark is a large-scale in-memory data processing framework, and so you already know that. So, okay. Then MLlib Is anyone not familiar with MLlib? Okay. MLlib is a component of Spark, providing common machine learning algorithm, and there is a lot of, regression, classification, clustering algorithm, and it's directly included in Spark. And now Spark Cassandra connector. Yeah. Okay. So it lets you expose Cassandra tables as Spark RDD, so you can perform analytics operation provided by Spark directly on the data stored in Cassandra. Okay, but before I build the model, I need to define the features of. Okay, so to do this, I just observe the curve, the time series representation. The first observation that we could make is there are two types of activities. There are repetitive activities and static activities. Okay, it's easy. And now, if you look at the graph of jogging, you can see, repetitive waves and peaks. And it's spaced about 250 milliseconds for the y-axis, okay? Now, it's for walking. It's quite similar, but this time the peaks are spaced out about 500 milliseconds. Here, it's for upstairs and downstairs, and yeah, it's pretty similar, actually. And to finish, it's standing and sitting. So after some tests with different feature combination and after reading a lot of study about this, I have chosen these features. So the acceleration, average acceleration, the variance, average absolute difference, average resultant acceleration, and the average time between peaks. Okay? So now, I will show you how to compute this feature, but before that, we need to clean and prepare the data because it's not directly usable. So for this, I just made a picture to explain. So you remember the data is recorded in a sequential way, and the data is collected from different users, okay? And at different time and date. So the first thing to do is to find the jumps between the record, okay? So here I retrieve the data for each user and activity. Then I have sorted the data by timestamp. And after that, here, I have defined the jump between the record, okay? And for each recording intervals, I need to know the length, and I need to define a window because I only have 47 users. It's not a lot of data, so I need to define a small window, 5 or 6 seconds, to have to have more data, to have many samples as possible, okay? And for each window, I will compute the feature. For each window, for each user activity, I can compute the feature. This is the last column. So here is the code to retrieve the data from Cassandra. It's Java 8. So, okay, I define a Spark context, and then here I use Spark Cassandra connector. I just call the user table in Cassandra, and it's create my RDD. And now I will show you how I have computed two of the features using Spark and MLlib. The first one is very simple. It's a mean. And to do this, we just have to use the mean function provided by MLlib. So it's very easy. And the mean function apply on a vector. So you've got the mean for the acceleration over x, y, and z, and you can apply the mean directly, and it returns a vector of the mean. Okay, now it's more complicated. It's the peak, it's the average time between the peaks. So here the first thing to do is to define the maximum, okay? To do this, I just use the max function provided by MLlib. And then I need to define what is a peak. So for me, a peak is a value that is greater than 0.9 times the maximum, okay? And to keep the peaks, I just use the filter function provided by Spark here. And at the end, I retrieve the timestamp for each peak and sort it. And okay, I want to compute the delta between each timestamp. So to do this, I have used the zip function to create one RDD from two separate RDD, you know. And here I can compute the difference between two successive values, okay? And to finish, I just use the mean function to have the average time between peaks. But if you want to look at the code in details, just go in my GitHub account. And now this is the predictive part. So not really the predictive part, but we have to choose the algorithm. And just to recap, we want to determine the user's activity from data, where the possible activity are walking, jogging, sitting, standing, downstairs, and upstairs. So this is a multi-class problem, classification problem. And MLlib provides you a lot of algorithm to do this. So for example, there is a decision trees in MLlib. So the first thing to do is to split the data set. The training set is used to build the predictive model, and the test data set is used to validate the model. And after that, you just have to use the function provided by MLlib. There is a train classifier function to build the model on the training data. Here, I just want to evaluate the model, so I use the predict function, okay, on the test data. And at the end, because I want to make some predictions, I save the model. Okay, the result. Okay, it's pretty good if we don't, without considering up and downstairs activities. So one idea would be to define more relevant features to have a better prediction model, okay? And, okay, the prediction part. I wanted to make a demonstration, but I had some trouble, so sorry, you want me running right here. But, okay, we will pretend, okay? So, I have my smartphone with an application, and we use a REST API. And with this application, you can collect the data, and the data are directly pushed in Cassandra. And this is, Amira, my friend. She coded this application, so you can find it on her GitHub account. And okay, the data are pushed in Cassandra. And okay, I run. The data are registered in Cassandra. And now I would like to predict which activity I was doing. So the first thing is loading the models. And after that, I use the Spark Cassandra connector to connect Spark and Cassandra and retrieve the data. And here, I select the last value in the table, okay? I compute the feature on this data, and at the end, I just apply the predict function to have my prediction. Okay, so we just see how to predict the activity your user is performing, but okay, how can I use this result? So maybe we could adapt the music our user is listening, depending on his activity. We could also detect if this person is not moving enough. Maybe we could create a specific program from him to encourage him to practice more activity. I'm sure you can have a lot of other ideas, but okay. And yeah, I'm not good to conclude, but it's the time to conclude. So, okay. Of course, the Internet of Things brings a lot of opportunities and challenges. Businesses opportunities, technical challenges. But for me, it's also a way to let out your creativity and foster many innovations. So I hope it was clear enough and that you had a lot of cool ideas on innovation application using IoT data. So thank you, and if you want to see the code of all application, it's on this GitHub.